Okay, so today's daily, we have already solved the problem, so we do the other one. This question called minimum genetic mutation. Okay. Okay. Okay, so it's given start Jenny and end Jenny and also the bank, and we want to make the start Jenny as end Jenny, and we want to try to find the minimum number of mutations needed. Okay. And what is the bank for? There is also a Jenny bank. Okay, that records all the valid Jenny mutations. A Jenny must be in the bank to make it a valid Jenny string. So what's that meaning? Okay. Okay. Jenny. Okay. 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 So one mutation is defined as one single character change in the Jenny string. Okay. All right. And we want to find the minimum mutations. Okay, so it looks like it's a graph. We can build a graph, and we can use the adjacency list to represent the graph. And each string could be a node, like the start Jenny is a node, and end Jenny is a node, and every string in the bank is also a node, and the age is defined as like where we can use okay, so if I can change just one character and make it as the other string in the bank or equals to the end Jenny, which means that we can have an age between these two nodes, and this is a single mutation definition, right? So AACCGGTT has an age with AACCGGTA, right? But it doesn't have an edge between the AACCGGT between AACCGCTA because there are two different characters, and we cannot just use one mutation to change from the start Jenny into the AACCGCTA, right? Okay, so the things that we have to do is define the graph. And since we want to find the minimum number of mutations, so we can use BFS to find the minimum path by BFS, right? And there are probably a early return that if the in bank. Check if in bank. If not, we can just do the early return, right? Okay. So okay, bank. Okay. Starts Jenny. Default ticked. This list. And I think this is a undirected graph. So okay. Okay, that's valid. Okay, so we need a function called valid, right? Just put it here. Diff counts 0 for I in range on length +1, and we can assure that S1 and S2 have the same length. So okay, so we can use this method, basically just two pointer and go through every character in the S1 and S2, and if the characters are different, we just increase the different counts by 1, and we return the different counts equals to 1 as a Boolean value. So, okay, so yeah, if the different count is equal to 1, which is true, and we want to append this age between these two nodes. Okay, and so if not in, we can just return -1. Okay, so result is -1, and we want to do the BFS, so we need the key over here, and we want to put the starts as start point. Okay, and we also need this set. Okay, then we just do the BFS. Step is 0 actually. Node. If node equal to end, we just return step. Oh, so we don't need the subgroup actually. And otherwise, we want to do for adj node neighbor in node if neighbor in visit. Continue. Also, we want to put the neighbor into visit set and append the neighbor into the queue, right? And after one round, we want to make step increase by 1. Okay, I think that's pretty much as a solution. Let me check it. Okay. Okay, so yeah, I think this is pretty much today's practice. And for this kind of question, there's some hint. First is that a hint from here, change a single character into a new string, like from initial string into new string. There's arrow here, right? So I would say you can see this as a graph. So its many question looks like this, and the famous one is with lidar, I think. So word lidar, I think. So yeah, it's not really uncommon. So I think it's kind of very intuitive for to think about graph. And the other hint over here is that we want to return a minimum number. And if we have a graph structure and we want to find a minimum number, we will think about the minimum step and the minimum path from A to B, which is usually used the BFS, right? And yeah, so the first part is that you have to come up with the adjacency list to represent the graph. And the other way, and the other things to do is you have to use a single pointer to for loop the two string to compare we should create an age between the two nodes or not. And then you just try to start from the start string and try to get the end string as soon as possible. So yeah, that's pretty much it.